Hi guys, we are starting 7.6 today, which takes a different route. We did law of cosines and law of sines at the beginning of the chapter. This is now going to focus in on vectors. So I just want you to watch this clip real quick.
I'm applying for a new film loan. Go by the name of Vector. It's a mathematical term. Quantity represented by an arrow with both direction and magnitude. Vector! That's me. Because I'm committing crime with both direction and magnitude. Oh yeah! Check out my new weapon. Hurrah, gun! Oh yes! Fires, glamours, never seen one. Oh, you have my advantage. Do a demonstration. Oh, ow! Sometimes
So that clip was just to show you what a vector is. Hopefully you caught on. He said it twice. A vector is a quantity that involves both magnitude and direction. A scalar quantity, on the other hand, is a quantity that involves a magnitude but does not have a direction. And magnitude just means a measurement or length, that they're giving you some kind of distance or something of that nature that tells you how long the vector is going for. So the first thing we're going to do real quick is just walk through what is the difference between a vector or a scalar vector. So if you look at number 1, it says moving a brick 5 meters. It gives you the magnitude, but it is not giving you a direction, so this is just a scalar measurement. Looking at number 2, it says you're moving a brick 5 meters to the right. This time it does have a direction, so this is considered a vector measurement. Number 2, it says traveling north. That is a direction at a speed of 50 miles per hour. That is a magnitude, so this is considered a vector. Number 4 says the temperature is 75 degrees. That's just a measurement. It does not have a direction, so this is a scalar vector, a scalar value. And take a minute with 5 and 6. See if you can figure out what those are if you want to pause the video for a second and then test yourself. Number 5 says a person is 5 feet tall. That's just a measurement, so it's just a scalar. And then a cart is pulled 100 feet. There's my measurement. Up an incline of 30 degrees. That has a direction. That means this one's a vector. So what we are focusing on now is the different pieces of a vector. So when we look at the picture of a vector, it looks like what's called a directed line segment. It's a segment that has an assigned direction. So it's a little bit more than a segment you would talk about in geometry. So it has a definite start point and a stop point because of the direction. So if you look at the picture on the right, the direction the arrow is pointing is here, would mean that P is the initial point, that's where it's starting, and Q is the terminal point, that's where it's ending. So a directed line segment is just another way of saying a vector. Excuse me. The magnitude of the vector is just figuring out how long it is. It's its length. So the magnitude of the vector is the length of the segment. Alright, in order to be equivalent vectors, they need to make sure that they have the same direction and the same magnitude. It's not just one or the other. It has to have both. So same direction and magnitude. So if you look at the examples, the first example, these are equivalent because they go in the same direction and they have the same length. These are not equivalent because they're not going in the same direction. One's a little bit more tilted than the other. These are also not equivalent because they are going in different directions, one pointing up and one's pointing down. And the last ones are not equivalent because they are not the same length. They're going in the same direction, but they're not the same length. So then we're just going to go through the visual part of adding and subtracting. I don't need you to be able to do this part, but just to show you what's visually happening. So I'm going to zoom in here on this picture. So So this problem wants me to add u plus v, which means I have to take the v vector and I actually have to move it. Its starting side has to be where u stops. So I'm going to take that vector and I would move it up to this, the end of that u, and that's where the v would go. That's how you visually would add them together. Then the u plus v part is actually putting the same starting point and the same stopping point of what happened when you put the two together. So this part here is actually the u plus v part. Subtracting is a little bit different. For subtracting, the first thing you actually have to do is you have to make v negative. So to make v negative, you have to go in the other direction. So that would go in this direction, the same length, but it's going to go in the opposite direction, that's negative v. And then you would move that up to the end of u, since we're trying to subtract it from u. It would move up there. And then the u minus v vector would be the one that starts at the same place as u and stops at the same place as that negative v. So this would be considered u minus v. So again, this is just to show you visually what's happening, and you'll see that this happens when we get to word problems with these, to find where our resultant is. The resultant force is that vector that connects the two together. So then a couple more things about vectors is you should be able to, if I give you a vector in what's called component form, you should be able to find its magnitude, and we're going to work towards also finding its direction in another lesson. So this is just about trying to understand what's going on here. So you're going to see, when you look at a vector, you're going to see that it's in the AI plus BJ form. That is actually two separate components. The AI component is the horizontal component. So there's actually a separate vector here that we could look at. That's the AI vector. And you'll see me put arrows over these on here because I can't write in bold. Your book, they're in bold, but the other way to write it is with an arrow. And then the other component is this one here, is the vertical component, which is the BJ component. To find the magnitude then, the magnitude is the length of that segment, which means we just have to do, if you think of that as a right triangle, you just have to do what? Hopefully you're saying Pythagorean theorem. It's just going to be a squared plus b squared equals, we're going to call it v squared for the vector. So to solve for the vector, you would take the square root. This is going to be our formula for magnitude. It's the square root of a squared plus b squared. So that's how you find the magnitude. So in the first one, I first need you to be able to sketch these looking at which component you have given out to you, and then we're going to find also the magnitude. So if I draw this out, the first component is telling me the horizontal component. So horizontally, I'm moving out approximately -2, 12. I'm not going to draw it exact. And then this part is the vertical component that tells me I'm moving up 5. My vector that I'm really looking for then is this guy right here. That's where the vector would be. So you need to sketch in the hypotenuse. That's the vector we're looking for. And then the directions also ask us to find the magnitude of that vector. So to find the magnitude, it's just the same formula. Every time it's the square root of a squared plus b squared. So it's going to be the square root of 5 squared plus -12 squared, which is the square root of 25 plus 144. You get the square root of 169, which means our magnitude for this particular one is 13. If you'd like to pause it for a moment and try number 2 on your own, I would encourage you to do that. I'm going to start in 3, 2, 1. So this one, again, we're doing the horizontal part first. The horizontal part is the I part. They always go, it's like a point, x comma y. So I'm going over +3. And then this is my vertical component. I'm going down -3. My vector is that line that connects those together. This is the vector that I'm actually looking for. And I need to find the magnitude of that vector. So the magnitude is going to be the square root of a squared plus b squared, which is the square root of 3 squared plus -3 squared. Just be careful when you're squaring a negative. it actually comes out as positive 9. So those are both positive 9, we get the square root of 18. And then I'd like you to leave this as a simplified radical. So it's going to be 3 radical 2, because 9 goes into it. Alright, let's try a couple more things with vectors. Alright, this next one, they are giving you the coordinates of the initial point and the terminal point of the vector. We have to write it in component form. So I'm going to do this visually first, but when you get to this part of the homework, there's also a way to do it that's not visually, and I'll show you both. So we're going to plot the point first. P1 is over -1 up 3. So over -1 up 3. That's P1. P2 is over 2 up 7. 2, 1, 2, 3, 4, 5, 6, 7. That's P2. So I know my vector, you got to keep track of your direction here. My vector right now is starting at P1 and stopping at P2. So what I need to do is I need to find the 2 components that are going to get me there. So I'm thinking about the horizontal component first, because that's what we write first in component form. So I get the horizontal component visually. I'm just literally looking at how far over does it have to move to get lined up with P2. That's moving over 3. So the horizontal component is 3. And then I also need the vertical component to get to P2. That's 1, 2, 3, 4. Had I gone down, it would have been -4, but this one it goes up, so it's +4. So the vertical component is +4. So then the answer in component form is just putting those 2 together with the I and the J. So it'd be 3I plus 4J. And that's your answer in component form. The other way to do this is just to look at your point and think of the horizontal change as the change in x. So the horizontal component is just the change in x, which means I would do 2 minus -1. That's how I get +3. And then the vertical component, if I'm looking at the points, is just the change in y, which is 7 minus 3, which is 4. But you do need to do, if you're going to do it that way, please make sure you do terminal minus initial. You have to do it in that order or your sign doesn't come out right. But there's 2 different ways to do it. You can do it visually, or you can do it just mathematically subtracting the 2 numbers. Alright, the next step is doing operations with vectors. So you can add, subtract vectors, and you can multiply them by a scalar, which means you're just multiplying them by a constant number. To do that, the rules are there, but it makes more sense if I just walk you through a problem. Excuse me. So the first one, I'm going to graph it just to show you that this really is the answer. So I'm going to graph V. V is over 5. V is over 5 up 4. 4. So this would be the V vector. And then W, if I went from there and added on W, W would be over 6. So I'm going to have to go over 6 from there. I did not pick good numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. It would end up here if I add that on to the end of that one. That's how, remember, we add them together. So then my result, what I'm looking for, is this vector. Is however big that vector is there. I didn't draw it very well. But that vector. It swings out a certain distance, and it swings down a certain distance, and that's how we get it in component form. You don't have to be able to do this visually, though. You just have to be able to do the algebra. So if I write this out, this would say I'm taking that first vector, and I'm adding it to the second vector. All I'm really doing is combining my like terms. These are like terms. Those are the horizontal pieces. I'm just going to add those together. I get 11i. And then, I'll put the little arrow on there. Plus, I'm adding the vertical components together. That's going to come out to -5j. So you could put plus negative, or you could just put minus. We'll put minus 5j. And that is the result. And if you look at that, that's actually the distances I have here. Is this swung out +11, and it went down to -5. So you can just do the algebra, but I wanted to show you that that's what it works out to visually. So we're not going to do the visual part of number 2. I just need you to be able to subtract those. So I'm going to write those out, but because we're subtracting, I'm going to put parentheses up. It's v, which is 5i plus 4j, minus the w vector, which is 6i minus 9j. All I need to remind you of here is when you're subtracting a group of numbers, you need to make sure you distribute the negative. So this is really 5i plus 4j minus 6i plus 9j, since I'm distributing the negative to the negative. So my answer is going to be negative 1i plus 13j. You're just adding the like components together. The I parts with the I parts, the j parts with the j parts. Should be pretty easy. Alright, then this last page, number 1, they're asking you to do scalar multiplication. All we want to do for number 1 is we want to do 6 times 5i plus 4j. And we're just going to distribute that 6 to both of these. So it's going to turn into 30i plus 24j. And that's your answer. And then for number 2, they want us to do negative 6 times the same vector. Or negative 3 times the same vector. I'm distributing the negative 3. I get negative 15i minus 12j. And that's my answer for that one. And then number 1 in the next set of examples just steps it up one more notch, is we have distributing a scalar and we have to also subtract. So I'm just going to plug everything in first. It's 4 times v, which was 5i plus 4j, and then minus 3 times w, which is 6i minus 9j. And then you're just distributing here. You get 20i plus 16j, and then I'm making sure I distribute the negative 3 here. That's minus 18i plus 27j. And then the last step is to combine. We get 2i plus 43j. And that is our vector. Alright, so I want you to do the class kick that I have assigned for vectors today, and then work on the homework. It is to be submitted to Schoology by class time tomorrow. It is out of the book, so please make sure that you are checking your answers before you send in which ones you have questions on the Google form. And I will be making a video again with the places where we have the most questions on the Google form, so please make sure you're filling those out and check in on the daily agenda just to make sure you're doing everything that is expected of you. Stay safe out there, and hopefully we can video chat soon.